Okay, students, once again, good morning to all. So in last session, we was discussed about introduction to the operating systems. So in that class, we was covered definition of the operating system, what operating system can do, and what are the major components of the operating system or computer structure. And we was also discussed several definitions for the operating systems. So we was also discussed about computer startup. What is meant by computer startup? What is meant by bootstrap? These all things, right? In this session, we can extending the same concept, introduction to the operating systems. So first of all, we will discuss what is meant by interrupt, how to handling the interrupts in operating system. So okay, so first of all, what is meant by interrupted? So in operating system, whenever any user or that particular computer user wants to perform some operations or some processes with that particular computer hardware. So for that purpose, so here user must be send some signal to the operating system. So that means here user must be send some signal to the CPU processing unit. So to send that particular signal, here the interface is the operating system. So that means here user was sending the some signal to perform some specific process by the operating system. So for that purpose, user was sending the some signal to the operating system. So here that operating system was forwarding that particular signal to the processor. So this is the process. So that signal transmission are sending the signal to the operating system or kernel. So that signal is known as the interrupt. So that why we call as interrupt means, so already we was discussed, always operating system was running the some program to perform the several processes. So at that situation, in that situation, if we want to complete any specific operation, if we want to complete any specific operation, so for that purpose, so it was interrupting the current processing unit or current processing process. So what is the purpose of that particular interrupt means, so here whenever we are sending some process request to the operating system, so at that situation the operating system was stops the current executed process, currently executing process, and then try to evaluate or try to complete whatever the process or whatever the request was given by the users. So that's why it was interrupting the current executing process. So that's why here whenever we are sending the signal to the operating system, that signal is called as the interrupt signal or interrupt. So now we observe what are these some common functions of the interrupts. So while we are going to performing the interrupts, so what are the several common functionalities of the interrupts? So here actually, just now we discussed. So here actually, interrupt was sending the some control signal. Interrupt was sending the some control signal to the operating system. So here that control signal is used to perform any specific process. So here whenever operating system was sending the interrupt to, sorry, here whenever any specific device controller like IO device controller or either memory device controller, so any device controller was sending the interrupt signal to the operating system at that situation. So those all interrupts are maintained as a some buffer memory. Those all interrupts are maintained as some memory. Why? Because in our computers number of devices was used to performing the user
Some
required.
screen unmuted, let's say.
Okay, so now is it okay?
Yes, sir.
Okay, right. So whenever it was any device controller was sending the interrupt signal, so those all interrupt signals are maintained as a some buffer memory. So that means why we are maintaining in memory means, so in our device, that means in our computer, not only single device controller was sending the interrupts at each and every time. So why? Because there are a lot of devices like memory device, IO devices, and any other devices like printers, and any number of devices was used by the computers. So for each and every device controller can sending the interrupt signal to complete their process, their required process. So that's why to maintain whatever the total number of interrupts was occurred. So for that purpose, we are maintaining these all interrupts as a some vector information. So already you know what is meant by vectored information means nothing but here we are maintaining those interrupts information in the form of some table, in the form of some table. So within that table, so it maintains which type of information means whatever the address. So in case for example there are four interrupts was occur, then this interrupt vector maintains which type of information, whatever the total number of interrupts, like interrupt 0, interrupt 1, interrupt 2, interrupt 3, interrupt 4, and so on. And interrupt 0 was occurred at which address, interrupt 1 was occurred at which address, interrupt 2 was occurred at which address. So such type of information was maintained in the interrupt vector. Here these interrupts was handled by the operating system obviously. So that means while we are going to designing operating system, so that operating system must be interrupt driven, that operating system must be interrupt driven. So that means it must be handling the such interrupts. So for that purpose, at the time of developing those computers or those hardware equipments, so those developers must be develop the proper architecture, develop the proper architecture to handling these interrupts. So whenever it was going to handling the interrupts at that situation, that particular device must save the address of the interrupted instruction. So whatever the interrupts was occurred, so those interrupts related instructions was stored in which memory location. So that type of information must be provided by the each and every architecture of the computers. So here while we are going to generating the interrupt, like, so here there are two kinds of interrupts was occurred. So one is the hardware components was generating the some interrupts, and another one is the we are using some program to generate the some interrupt signal. So whenever we means nothing but some memory device controllers, so these device controllers was generating the interrupts means those are developed or generated with the help of some program. So that is called a the trap or exception. So we are using some program or software to generate the interrupts. So those interrupts are called as the trap or exception. In case any interrupt was generated by the hardware components, so not by the controllers, directly generated by the any specific component, then those are called as the some errors. For example, whenever we are trying to access the input from some input device, in case that input device was currently not connected to the such device, at that situation it was producing the, sorry, it was generating the some interrupt in the form of some error message. So these are the several functions of the interrupts. So now we observe how to handling the interrupts. So already it was discussed. So to maintaining the total number of interrupts, those number of interrupts was generated by the which device or which memory location. For that purpose, we are maintaining the some vectored information, some vectored information. So that is a vectored interrupt system. So vectored interrupt system. So another type of interrupting is polling interrupt system. So actually here there are two types of interrupts. Those are vector typed and another one is the polling type interrupt. So already we know what is meant by vector typed interrupt. So here total number of interrupts are maintained in a database. So whatever the total number of interrupts was occur, each and every interrupt is performed by the performed at or occurred at which memory location. So such type of information or such type of interrupts is known as the interrupt based, sorry, vector based interrupts. And another one is the polling based interrupt. So here polling or polled interrupt means nothing but so which is a some specific type of input, that means IO. So which is a some specific type of IO interrupt. So that means by simply, so there is some interrupt was generated by the computer. So that interrupt was generated by the some specific IO device or some specific IO interface. So such kind of interrupts is known as the polling interrupt. So that means that particular interrupt was occurred by the some specific input device or some specific output device. So then we can say is that that particular interrupt is known as the polled interrupt or polling interrupt. Vector interrupt means it can form, there was some interrupt was occur or generated by the any device of the computer. Only input device generating the interrupts, only input output generated interrupts is known as the polling based interrupts, and remaining any interrupts was any devices was forms the some interrupts is known as the vector based interrupts. So these are the two types of interrupts are used in operating system to handling the interrupts. And here based on the type of interrupt, here handling methodologies is also different. In case that interrupt is formed in the form of polling based interrupt, then we are using one kind of functionality to handling such interrupt. In case that interrupt was formed by the vector based interrupt, then we are using some another functionality to handling that particular interrupt. So these are the two types of interrupts are commonly used to handle the interrupts in operating system. So here we can observe some interrupt timeline. So actually whenever OS was runs the whenever OS was running their program at that situation, so this is the timeline. So in case any device was interrupting this operating system, then it form the interrupt, and within this duration it will try to handle that particular interrupt. So in case is there any process was requested to executing their instruction at that situation, so this is the timeline. After completion of this execution, again go back to the previous state of the CPU. So in this manner, so in case we are that particular interrupt was formed by the any IO device, so here initially it was waiting for getting the instructions from the any IO devices. So whenever it was getting the interrupt message from the IO device, then it was handling the that particular interrupt. After completion of that interrupt, again go back to the previous state. So in this way, so it was handling the interrupts. So now we can discuss how we are arranging the several IO devices, and how IO devices was interfacing with the operating system. So here while we are going to observing the IO structure, basically any computer's IO structure is basically any one of the two formats or any one of the two types. So one is the first type of IO structure is so once IO was started, that means either input or output device was starts the sending the signals, then control returns to the user program only. So here whenever IO device was starts their execution or their data transmission, then their completion of that particular IO instruction is controlled by the user mode or user program only. So that means after completion of the current executing program or current executing process, then only it was takes the another IO interrupt. So another IO input. So that is the one method. Another one is whenever IO was started, control return to the user program without waiting for the IO completion. So one is the So whenever IO device was started, first methodology is it doesn't wait for the current IO completion. And currently it was processing some input or output processing. So it was waiting for completion of the currently executing instruction. After completion of the current execution, immediately it starts their data transmission or instruction transmission. That is the one methodology. And another methodology is once IO was started, here control to the user program was not wait until completion of the current IO execution. So these are the two things. One is the waiting until completion of the currently processing IO. Another method is it doesn't wait for the currently processing IO. So it immediately starts their instruction execution. So these are the two kinds of structures was used in the IO. So coming to the first one. So whenever it was waiting for currently processing IO completion at that situation, so here IO instruction was must wait until CPU was idle. So whenever currently CPU was processing any process at that situation, so here it was wait until completion of the currently executing process. After completion of the currently executing process, it was sending the some interrupt message. So for that purpose, it was wait in the some loop. Why? Because it was continuously try to accessing the that particular CPU. That's why it was wait in the loop. And here at most one IO request is outstanding at a time. So that means at a time only one IO request is processed by the CPU, and one more IO request is waiting for the CPU availability. So that is the process of IO structure in first category. Coming to the second category. So in second category, here control system was, that means device control system was not wait for the currently processing IO request or currently processing IO. So at that situation, it was using the some system call. So here the system call is used to requesting the operating system allow the user program or user requested IO. So for that purpose, it was using the system call. So here system call means nothing but it was used to requesting the operating system. It was used to requesting the operating system. ఏం రిక్వెస్ట్ చేస్తుంది టు ప్రాసెసింగ్ సమ్ IO. So for that purpose, we are using this some system call. And here one more thing is we are also use device status table. Device status table. So here device status table means nothing but it was having some entry for each IO device. So just like some buffer memory, so it was maintain whatever the total number of IO entries, those all IO entries are maintained as a some buffer pool or some buffer memory or some memory. So just like some table format. So that is nothing but a device status table. So this table contains which type of information means what are the total IOs was generated by IO requests was generated by that particular computer, and which type of IO. So what is the it was belongs to the which type, and wherever it was stored, that means their address is located at where, and what is the current status of that particular IO request. So such kind of information is maintained as some table format. So that is nothing but device status table. So here OS can able to indexing IO devices to the table. So this device status table to the IO devices. That means so here operating system can able to having proper information about whatever the total IO request was waiting at IO device table and their indexes, that means their addresses are their original memory locations. So such type of information can be maintained by the operating system. So these are the two types of IO structures are used in the operating systems. And next very basic concept is storage definitions and notation. So that means while we are going to store some information into the computers at that situation, how we are represent or how we are representing that particular data or that particular memory. So in which format, whatever the notation. So already you know very well about what is the basic notation of the storage unit. So actually, whenever we want to store single bit, single symbol or single character into the memory, if we want to store something into the memory, so that is represented basically in the form of bit. So here bit means nothing but, so here bit is nothing but, so which is some memory location. So that memory location can able to store at a time only one symbol, so that is either 0 or 1, either 0 or 1. So that is nothing but a basic unit of the computer storage. So next, so here while we are going to using any computer storage units, so those storage units is basically collection of the some bits, collection of the some bits, that is nothing but some bytes. So here whenever we want to maintain that particular data in the computers, for that purpose we are using some collection of bits, that is also referred as byte. So already you know what is meant by byte. So here byte is a collection of 8 bits. So why we are so already we are using the bits for storing the data, why we are representing the byte means to easily or conveniently representing the instructions. So for that purpose we can use some collection of bits is represented as the 1 byte. So that is nothing but collection of 8 bits as represented as 1 byte. After that we know either collection of 1024 bits or 1024 bytes is known as the 1 kilobit or 1 kilobyte. So that is either collection of 1024 bits is 1 kilobit, either collection of 1024 bytes is 1 kilobyte. So after that megabyte, after that gigabyte, after that uh, petabyte. So these are the memory representations in our computers. So kilobyte, megabyte, gigabyte, terabyte, and then petabyte. So actually in our computers we are representing data is in the form of bytes, which may be kilobyte, which may be megabyte, which may be gigabyte or terabyte or petabyte. But coming to the networks, whenever we are transferring such data through the networks, at that situation such information can be represented as in bits only. So megabits, kilobits, gigabits, either terabits, petabits in this format. Why? Because in computer networks data can be transmitted in the form of bits only, so at a time some number of bits only. So that's why while we are going to store the data in networks, at that situation we can represent memory representation as bits. And while we are going to storing the data in while we are going to storing the data in computers, at that situation we are representing the data in bytes. So these are the memory representations. Next, storage structure. Next concept is the storage structure. So that is how we are representing the storage units in our computers. So while we are going to store the data into computers, at that situation, so here entire storage is classified into several categories or several storages. So those are main memory, secondary memory. So those are main memory and secondary memory. So here main memory means, so it can only it can store some amount of data in temporary manner. So we can store some amount of data in temporarily, so that means volatile. So secondary memory means we can store the data in permanent way. So that these are the two types of storage structures are used in computers. So So not only these two types, some other types also use it, but commonly we are using the to store some huge data either in primary memory or secondary memory, either main memory or secondary memory. So already you know what is meant by main memory and what is meant by secondary memory. So simple examples for the main memory is either RAM, random access memory, and simple examples for the secondary memory is either hard disks and solid state disks, so that is ssd, hdd or ssd. So these are the two types of secondary storage devices commonly used in the computers, and main memory is random access memory. So coming to the secondary storage, so actually which is a non volatile memory. So secondary storage is the non volatile memory, so that means it can permanently store the data into such storage devices, so that is the secondary storage. So for example, consider hard disk. So we can store whatever the data we want to store in the hard disk. That data can be available at any time. So it was permanently available. So in case we are storing some data in RAM or main memory, then what is the problem? So such information is available only until turn offing that particular PC only. Once we shut down that particular PC and again starts the PC, then such memory is not available. So that is. So but whenever we are storing the data in hard disks, at that situation, so we must we can permanently storing the data, and we are accessing that particular data at any time after power failure also. So that's why we are saying that main memory is a volatile and secondary memory is the non-volatile. So in hard disks, whatever the structure already you know, whatever the basic working process of the HDDs. So here we are using the some head. So that head was used to read the data from magnetic tapes or magnetic disks. So inside the hard disk we are using the several magnetic disks. So those disks was divided into several tracks. So again these tracks are divided into several sectors. So here data was stored in these either some number of tracks or some number of sectors. So to read that particular data from those magnetic disks, so for that purpose we are using this some header. So that is the mechanism in hard disks. So that's why it was taking some long time to accessing the data. Whenever we are using the ssd, so it was faster than the hard disk. Why? Because here there was no mechanism to read the data from magnetic disk or to store the data into the magnetic disk. Directly we can access or we can store the data from the ssd. Why? Because this is like some flash memory, like pen drives or memory cards in this way. So that's why here ssd is the faster than the hard disks. Next, storage hierarchy. So here whenever we are going to storing the data into computers, at that situation we can use different levels of memory or different levels of storage. So that different levels are those hierarchy was mainly represented based on the three categories. One is the speed of the memory, and another one is the cost of the memory, and is it volatility or either is it volatile, and they based on the volatility. So here speed. So here based on the different types of memories, their memory speed will be varied. So for example, we are using the register memory, we can access with the more speed. In case we are using either cache memory, we are accessing with some little bit speed to compare sorry, some little bit slower than the register memory. We are using main memory, which is some little bit slower than the cache memory. In case secondary memory, which is slower than the main memory. So in this way, so based on the speed, we can arranging the storage structure in several in different order. At the same way, based on the cost also. And volatility means nothing but is it permanent or temporary storage. So the based on these three factors, we can arranging the total available memories in different order. So now first of all we know what is meant by caching. So whenever we are trying to copying the data from one device to another device or from one memory to another memory. At that situation, to complete any specific process, we are transferring the data from slower speed memory device to higher speed memory device. So that concept, that process is known as the caching. That process is known as caching. So that means nothing but, so if we are moving the data from secondary memory to main memory, so here main memory is the cache memory for secondary memory. In case we are moving the data from main memory to cache memory, so here cache memory is the backup or caching for the main memory. So in case we are transferring the data from cache memory to register memory, at that situation here register memory is the caching from cache memory. So in this manner. And next, while we are going to arranging the total storage in our device in some proper order, for that purpose we can use the device driver also. So this device driver is used controlled by the IO manager. To managing the IO devices, for that purpose we are using the some device driver. So why we are using this particular device driver means, so to providing the proper interface between the controller and the kernel. So for that purpose we are using device drivers. So for example, we are installing the operating systems. After that immediately we will try to installing some drivers related to our computer, like audio drivers or video drivers or USB drivers, these all things. Why we are installing these all device drivers means, to properly providing the interfaces between the that particular device to the operating system, from IO devices to the operating system or from memory devices to the operating system. So for that purpose we are using the device drivers. So now we observe what is the storage device hierarchy. So this is the hierarchy of the storage devices in our computers. That is the first hierarchy is register memory, after that cache memory, after that main memory, after that SSD, again hard disk, after that optical disk, after that magnetic tapes. So these are the storage device hierarchy. So in this, from top to bottom, from top to bottom, their memory size will be increased. So that means compared to register memory, cache memory size is high. Compared to cache memory, main memory size is high. Compared to main memory, SSD size is high. Compared to SSD, hard disk size is high. Compared to hard disk, optical disks is high. Compared to optical disk, magnetic tapes is high. So in this manner. At the same way, from top to bottom, their memory speed will be decreased. Memory size will be increased, but memory speed will be decreased. And at the same way, from top to bottom, their cost is also decreased. Their cost is also decreased. So these are the several storage hierarchies in our computers. And next, caching. Just now we was discussed what is meant by caching. Whenever we are transferring the data from one device to another device, to accessing that particular data fastly, for that purpose we are using the caching concept. So for here, while we are going to using the cache memory, the important principle or the major formula is okay. So first of all, while we are going to executing any specific instruction, for example, we are going to executing some specific instruction. At that situation, first of all, that particular processor was checks. So that particular instruction related data is available in register memory or not. That particular data is available in register memory or not. So in case that particular data is available in register memory, then directly starts their execution. In case not available in the register memory, then it was checks in the cache. So the same data is available in the cache memory or not. In case available, then copied into register memory. So in case not available, then again it was accessing from the main memory. So so now it was checking that particular data is available in cache memory or not. In case not available, then go to main memory. So in case it was still not available in main memory also. So at that situation, we will try to access that particular data from the secondary storage. So in this manner, so by simply we will try to executing any instruction, we prefer faster storage. So that is the simple logic in cache memory. And next, whatever the several operating system operations, so how we are performing the operations in the operating system. So actually here in operating systems, every operation or every instruction was performed in which manner? Interrupt driven. So that means it was sending the some signal to the operating system and then processing that particular request at that particular process. So that is the basic process to performing the any operation through the operating system. So here to sending that particular interrupt signal, which was divided into two categories. One is the hardware interrupt and another one is the software interrupt. So here hardware interrupt means nothing but that interrupt was formed by the any specific device, maybe IO device, maybe storage device, or maybe any other device like printer or any other. So such type of interrupts is known as the hardware driven interrupts. And whenever any specific interrupt was formed by the software or some program, so then such kind of interrupt is known as the exception or trap. So like some errors, like some software errors like either division by zero, so at that situation it was giving the some interrupt. Either we are requesting the some operating system service, so for that purpose we are using the system call, that is also some program, so that is also software interrupt. So in this manner basically we are using the two types of interrupt operations to handling the any services with the help of operating system. So in this process, here operating system was basically supports the two types of interrupt handlings, two types of operations. Those are the single mode operation and dual mode operation. So here dual mode operation means so that particular operation can form by both modes. One is the user mode and another one is the kernel mode. So in case any specific operation is only allows in the user mode, then that kind of operation is known as the single mode or only performed by the kernel mode. So any one mode, so any specific process or operation is performed by the only one mode, then we can call as single mode operation. So in case it was formed by the both modes, then we can call that dual mode operation. So here basically operating system can allow both types of both mode of operation, single mode operation and kernel dual mode operation. So here single mode means nothing but that particular operation can runs only any one of the operating system mode, so either user mode or kernel mode. Dual mode means that particular operation can runs on both, so that kind of operations is known as the dual mode. That's it. So now we can observe how any specific control or any specific interrupt, any specific control signal was transferred from one mode to the another mode, that is from user mode to the kernel mode or kernel mode to the user mode. So here for example already was discussed, while we are going to access the uh, any system call or any process through the operating system, it must be waits on the loop. So at that situation, so here there is some timer like some counter. So whenever that counter is zero, so that indicates there was no other process was waiting for the operating system to handle. So whenever that counter is other than the zero, that means some other process was waiting for the operating system to perform their specific process. So in this process, whenever we want to execute any instruction, so for that purpose, first of all, that particular process was created by the user mode. That particular process was created in user mode. So that is nothing but by using the user process execution. So this one, so this is the, so this entire indicates the user process or user mode, and this one is the kernel mode. So here first of all user was interfacing with the user mode. So here we are sending some instruction. So to execute this particular process requested by the user, so for that purpose we are using the system call. So we are using the some system call. So now this system call is responsible for transferring our request, whatever the our required request, to the kernel, to the operating system. So for that purpose it was check what is the value of the mode bit. So in case that mode bit value is 0, then immediately send that particular interrupt signal. So in case that mode bit is other than 0, then it will wait until getting 0. So here what is the mode bit means? So currently kernel mode was running any specific instruction or not. In case it was currently running any process, then their mode bit value is 1. In case it was not runs any process, then their mode bit value is 0. So that means by simply kernel was busy or idle. So in case it was busy, then 1. In case it was idle, then 0. So here system call is responsible for, it will wait until getting the system is idle. So once it was getting the idle, so then immediately transfer that particular process execution to the kernel mode. So after processing that particular uh, instruction execution by the kernel, then it can return to the user mode. Why it was returning such control to the user mode means to storing the values into the memory or to getting the proper output. So for that purpose, after completion of the kernel mode execution, it was sent back such resulted information to the user mode. So this is the process of transmission from one mode to the another mode. Okay, it's enough. In next session we can discuss process management, memory management and storage management.